right. There we go. Everybody see my screen? Yes.
Yep.
Good
Yes.
stuff. So the way it works, you guys have had your hands-on training, or so the people that attended the hands-on training with the X7. You go out to your job site, you do your scans, everything gets registered in the tablet. So registration is building the puzzle. So as you guys are scanning, each scan is independent from the previous one, and it's like building a puzzle with our kids. We put the pieces together, and at the end, well, guess what? We have a building, a full building. That's our point cloud. We take this point cloud and we export it out of the tablet. At this stage, we're ready to work, and we can work directly on the point cloud, but sometimes, or I'd say probably most of the time, it's overkill. We got too much points. We got areas that we don't really care about that we probably want to clean up and get out of our ways so we can better see our points in our design in Revit. So that's the purpose of Cloud Engine here. It's to clean the point cloud and make it more user friendly and easier to work with. So from the tablet, you guys will be sending or exporting the scan files under the TZF format. So it will generate a folder with the job name underscore TZF. This is what you guys want to copy off the tablet and bring it over to your network or somewhere on a drive in your office. Now, when working with point clouds, we always want to work on your local disk or hard disk. We don't want to work or store the data on OneDrive or a server drive and be working on a remote computer. There's a lot of read and write to the disk and uploading and downloading to the memory when working with point clouds. And then the longer the path is to reach where the data is stored, well, the slower your software is going to respond. So make sure you bring everything over to your laptop or PC and you work locally. Once you're done, at the end of the day, you can then archive it or save it on a server. But the next morning, if you want to keep on going or someone's going to take on the lead at that point, he can copy it over to his local computer and keep on working. But it's very, very important because a lot of read and write to the disk. So that TZF folder is what you want to copy over to your computer, and then you can start working with the Office software. So Trimble Cloud Engine, right up here, it's this little blue icon. I don't know who's installed it. Was it installed on your end at PML?
I ran the installer, but I don't see any icons on my desktop or anything.
Okay.
Oh, I did. Never mind. I actually do.
All right, no problem. So
it was hiding.
There's only you, Robert, I think, that has it for now. Like I said, we can provide a trial license as long as you let me know how many people you want to provide a trial license. We can give you those for 30 days after the training to practice.
Yep.
So today, I think to make it a little bit more interesting or fluent for everyone, you can follow along, Robert, if you wish to, but I'm not going to give guided exercise or ask you to do specific things on your end, because then we got like 9 people that are waiting for you to get it done. So if you're okay with this, I'll just fly through the training, make sure we got all the steps lined up, and then I'll share the recording and you can redo the exercises. It's usually pretty simple for Revit users to get the gestics of Cloud Engine. So Cloud Engine gets installed on your computer right here. So you double click on Cloud Engine, pretty straightforward. It's going to open up on my screen 1. I'll switch it over to screen number 2 as soon as it's opened. And come on, Cloud Engine.
Jason, do you have it installed on your computer? Just when I'm trying to use the lice activation key, it says it's already been used.
I did the install, but I never put in any of the activation stuff.
Okay.
I tried to install it too, and with the activation key, and it said the number of licenses has already been exceeded, or something along those lines.
Maybe Juan used it when we were doing the tutorial the other day. So whatever computer that's on.
Well, We can try to fix this. Whoever has Trimble Cloud Engine installed on their computer, they can start it. And usually we reach this page or property page or project page. And then under licenses right here, we're going to see who's got the key activated. So the person that has deactivate this computer is the one that has the key. And if you don't find it, not the end of the world. At the end of the training, one of you guys send me your key and I'll check with Trimble in the database who's got it and if we can deactivate all users, and then I'll reply and say, all right, the key's been freed up. One of you guys can install it. So this is where you can deactivate. So if you guys don't decide to go convert this to a network license and say we're just going to share the key, this is where you deactivate it from one computer, and right after you can reactivate on another computer and pass the key like this quite easily. All right, so I've fired up Cloud Engine. Main menu is listed up here. So file, everything that's related to job management, projects, open, new, import, save, close, pretty straightforward. Select menu will allow us to do some point selection, fit points demolition. Display will allow us to manage our display, do a clipping box, change our view, colors. We've got a BIM lister. So if we bring in a BIM model from Revit and we have lots of information, we can kind of filter out if we just want flanges or just pipes, or just in the structure, in the steel industry, sometimes we just want the columns. Or so that's our BIM lister here. We got our transform tool that we're going to be looking at today, which allows us to move point cloud or model, one or the other. But in the point cloud world, or in the BIM world, I should say, the model is the center of the universe, so we never move the model. We always bring the point cloud over the model, and we don't do the other way around, because then when we export the point cloud to Revit, the point cloud is going to be elsewhere in space. So we bring everything over the model, typically. We've got some registration tools, but like I mentioned a few minutes ago, the X7 takes care of registration in the field. And we want registration to be perfect when we leave the job site, because if we have issues in the field, the issues are going to be the same in the office and we won't be able to correct them. So correct your registration issues in the field. It's going to save you a whole lot of time when you come in the office, and we might not be able to fix them in the office. There's no magic that's going to happen with the data. If you have issues at one place, you'll have them in the office. We have our points menu to manage the number of points, apply filters, check some overlap. Our validation tools, so floor inspections are going to be ran with these tools here. As builds to compare new builds against model files. It's going to be a deviation. We've got clash detection that's available too. So if you guys want to check your designs in a renovation or a retrofit, make sure that your model's not clashing in any existing structure. We can do this under Cloud Engine. I know Navis is capable of doing it too, but depending on which one you like most, maybe Cloud Engine will be a good tool to use. So few analysis that we can do here, very interesting. And we have a create menu to create different things, measurements, volumes, lines, polygons, shapes. Sometimes people with the CAD background will ask me, can I draw a line and a rectangle and a circle? The Cloud Engine is not a CAD software. It's not like AutoCAD. It's not like Revit. So what we create are shapes, or best fitted shapes on point clouds, right? So it's not like drawing in AutoCAD or Revit. It's a bit different. We can share the information so that if you guys are interested further down the road, when you guys are able to walk or run using Cloud Engine, we can circle back, have another meeting session where I can show you how we can share or publish our point cloud, so stakeholders, project managers can have a look at the point cloud and the model. Yes, Jason?
Oh, sorry.
Oh, no worries. No worries. I thought you had a question. And then we have our My Menu. This allows us to configure our menu with specific commands that we often use. So if I go back, let's say to select, and I do select points very often, I can add it to My Menu. So when I go to my menu, I now have this. Rather than jumping around menus, you can kind of customize your own palette or tool palette here with some menus. We got the online help. I'll come back to this icon in a few minutes. Just finish the interface reviewing. So we got our reporting units. We can report in any units with point clouds. It's just going to adjust it. It's not going to scale or switch or break anything. So we can just change them on the fly as we go. Our point scale here is the size of the points. So when we bring in a point cloud, it's a bunch of points. Well, how big do we want to represent those points? So we can adjust the scale of the points here. We got our views, so home, the view, front, right, or front, left, right, top view, orthogonal, perspective, projection, or orthographic, sorry, the other way around, perspective, orthogonal. We can go in a 360 view, so be sitting on top where the scan was taken on top of the tripod and view the point cloud from that perspective. So this is the 360. And we have our toggle button here to toggle our clipping box. So we can create clipping boxes, but sometimes we may want to see the full point cloud or the full region. So we can clip, unclip, and clip very quickly with this button here. Right underneath here is our tool window or our tool box. So every time you open up a tool, let's go to select points, see the tool comes and opens up right here. So during the training, or if I give you help later down the road, and I say go to the toolbox, this is where I want you to drive your mouse. It's in this area, because then we've got different things that we can do depending on the tool that's open. We got different options. So then I may say go to the third row or third line, see that rectangle with the black and white. This is do this or do that, or go to the last row, first icon. So this is where all of our tools get open and are accessible to be configured. We got our object list. So every time we create something, we create a measurement, or we import raw scans, or we import a model file, they all get listed down here. And this is where we can hide them, make them visible, lock them, delete, whatever, organize them. So this is our object list that's here. Other than that, in the interface, we have a command bar that's hidden right here. So you can click on the little arrowhead, or if it's not visible, as soon as you start typing, it will pop up. So as soon as you type on your keyboard, this will become available. We got some little tips here that will show up, so to select something, it's a long mouse press, a long left mouse press, set the pivot camera, spacebar will orbit and stuff like that. So you'll have some little tips here circling as you use your software. If I go back to my menu, I'm going to jump in the help just to show you guys a few things. So let me fire up the help. It's online help. It's very well made. I really like the way they design and they built their online help. We'll go and look at the getting started. So the main concepts that we have with Cloud Engine when we're using the software, there's a couple of things we want to have in the back of our minds to make sure we understand what we're doing or where we want to go and how we want to achieve it. I did talk about the command line in which we can enter logical names. Some users, AutoCAD, Revit, whatever. If you guys are used to typing commands, Cloud Engine tried to mimic or replicate the same commands. So there's a list of the logical names that Trimble Cloud Engine understands. I can quickly show you these. So if you want to draw a line in AutoCAD, it's LI. You can type in LI and it's going to open the create line command. If you want to do a dimensions, you can click dim and it's going to allow you to, it's going to start the measuring tool. It's going to open up the measuring tool. So there's different logical commands that are available. If you guys want to study them or try them out, just give them a try and you'll see it's going to open up a tool. So which one do I like to show sometimes? It's model view. See, we've got clip, CL, clipping, scope, limit, model view. If you type in any of these, it's always going to open the same command, which is the model view tool that we have there. So that's for the logical names. Just going to go back once. What one of the main concepts that we have to keep in the back of our mind when we're working with Cloud Engine, it follows a what you see is what you get concept. So if I see something on my screen, I've got a clipping box and I've got a reduced number of points in that clipping box, and I say export, what you see is what you get. You're going to export what you see, and that's it. If you want the entire thing, well, just let go of your clipping box and export again. So what you see is what you get. Very, very important concept to have in the back of our minds when working with Cloud Engine. I would say if we want to do like a floor inspection, let's say, or I want to do a deviation analysis, compare the point cloud to my model for comparing my as-builts. Well, if my model is not visible and I run the command, nothing's going to happen. I'm not seeing the model. So if you want to do a deviation analysis against the point cloud and a model, both need to be visible. What you see is what you get, just to give you another example here. We can drag and drop to import files, pretty straightforward. The default tool is this object select. Another concept that we need to keep in the back of our minds at all times when working with Cloud Engine is the second last one, which is a selection action. If I want to transform or move something, I have to select it in the object list first. I got to select the object that I want to run a command on. So selection of the object and then launch the action. I still get caught. Sometimes I want to export something and I'll go in the export tool and I click export and it goes like in a finger snap. I'm like, something went wrong. What the heck? I forgot to select what object I wanted to export. So it's a selection action. Same thing if you want to move the point cloud around. Well, you got to select the point cloud and then launch the move command. Because if you launch the move command or the transform command, I should say, well, you'll be like, where's my gizmo? How can I want to move my point cloud, but where's the gizmo to move it? It's not available because you didn't select anything. And last but not least, the object transform. So when we want to move stuff around, we can follow a hierarchy that's based on leaf, branch, and tree concept. And I'll talk about this in a few minutes when we import the scans. So the scans are the leaves, right? They come from the scanner. They're registered in FieldLink, and we export them and send them to the office. We don't want to break the registration. We don't want it to do this. We want them to stay as they are because the puzzle is all built, right? We did this puzzle with our kids. We don't want to throw it on the ground and break everything and have to restart again. So the leaves, we will group them to make a branch. Then we'll be able to move them around. Because if we don't group them and create a branch, the leaves are going to move on their own and then we're going to break our registration. So we don't want to do this. So that's the last concept of the tree branch leaf to manipulate objects. So super important. What you see is what you get. Selection action and the object transform hierarchy that I will re-emphasize as we go deeper in the software. The graphics window, left mouse button to do some object selection, control left mouse button to orbit, middle mouse button to pan, right mouse button to orbit, contextual menu with a long press of the left mouse button. Spacebar will reset the view. So as you play around with the software, you'll figure those out. Pretty straightforward. We won't talk about the object list here, not required. And then we have our main steps that we are going to do every single time we start a new project in Cloud Engine. We are going to do those 4 steps here every single time. We're not just going to do step 1. Our goal is always to reach step number 4. And this is what I'll be showing you guys today. So step number 1, pretty straightforward, import our data. So we're going to create a project. We're going to import the raw scans or the scan files. And if we have a model file, we are going to import that model file. Step number 1, pretty straightforward. Step number 2, we're going to do part of it. Sometimes we won't do it. Sometimes we'll do part of it. Why? Because registration of the scan data, you guys bought a Trimble solution with a tablet where registration happens in the field. We don't need to do it in the office. Woohoo, we're gaining time. This is a big game changer and time saver for the X7 users because registration does take a lot of time, but we have this done in the field. So complete the registration, we're not doing it. Sometimes though, we'll do, I'll call it step 2B, where we are going to import a CAD model. If you're doing an as-built and you want to QA/QC your as-built, then you might want to bring in your Revit model inside Cloud Engine to run your deviation. So you're going to set your project coordinates and you're going to import the CAD file. And then you're going to move and align the scan data to the CAD model. Like I mentioned, the CAD is the center of the universe in the BIM world. We don't want to move the CAD at any time. So we're going to take the scan data and bring it over the point model or the CAD model, sorry. This last step, you guys will not be
sorry,
doing.
JP.
Yes, Tim.
Quick question. Is there a way to just easily pick like a point cloud, like a wall, and match it with a wall or something like that? So that you can kind of just gonna go boom, it is auto corrects?
Yes, I'll talk about the three methods. We have three ways of aligning a point cloud over a model. So I will review those in a few minutes. Tim, no worries. And if I don't answer all of your questions or if it's still question marks in your mind, let me know. I'll be happy to explain or listen to you again and your question. So the last step, register survey data. We don't do this very often, and I doubt you guys are going to do this. So once we've positioned our point cloud over our model, this is where we're going to start to massage the data. That's how I call it, or clean it up a little bit. Reduce the number of points, clip out some specific location and areas, and then this is where the road kind of divides into on step number 4, where we will, either export the data or optimize it, and then send it over to our CAD or design platforms, or stay in Cloud Engine and start doing some analysis. So again, online help, getting started. If you look at this here, you'll be pretty much ready to start using your software. There are some tutorials, so if you guys get good at it and you're like, all right, let me try to do a floor inspection, an ASTM 1155 floor flatness, floor levelness, you can watch the recording and try it out. There's a few deviation analysis here if you want to check elbows or pipes or whatsoever. So you can kind of look at that as you go. Software downloads. So when there are updates showing up, or if you want to install the software on another PC, you can share the link here and just download the Trimble Cloud Engine application, which is the first one. This is the Trimble Explorer that allows us to share point cloud information. So like I said, later down the road, if you guys want to look at this, I'll be happy to get on a call with you, but this is free. As long as you have the published data and the Explorer on your computer, you're good to go. So it's pretty much like Word in a Word document. If I have Word document and I have Word, I can view it. So that's how it works with Cloud Engine, and this is free. So people like free things, and we're having success with this little tool here. And the nice thing is that this here, the data can be stored on OneDrive. As long as you just sync it on your computer, then you can view it. So most of the people will publish on OneDrive or Google Drive or Dropbox, and then just share the link where the published data is stored. Launch the app, the Explorer, and you guys are going to be able to view some projects. And we've got some Autodesk plugins here, which allow us to transfer directly from Cloud Engine to Revit, and Revit from Cloud Engine some data around. Really cool, but it requires to have both pieces of software installed on the same PC. So if you have Cloud Engine on your computer and AutoCAD, you can send data from Cloud Engine directly to AutoCAD, and do the other way around, send data directly from AutoCAD to Cloud Engine. If you don't have both, you can always export from Cloud Engine into an RCP format. This is the Autodesk supported point cloud format, and send your whatever lines, shapes you've made or planes into a DWG, and then attach them in Revit or AutoCAD as reference files.
So it's not just AutoCAD, you can actually import it straight into Revit using this plugin?
Yes, the 3 softwares that are supported are AutoCAD, Revit, and Navisworks. I might do it today in the training if you guys are interested in seeing this. I have very little knowledge in Revit. I probably look like a fool, but I can try to fire up Revit and open up a 3D plan and send and receive data to Revit if you guys are interested in seeing.
Yeah, that'd be great. Thanks.
Cool. And then we got the rest of the online help for the commands, the project manager, shortcut keys. So I'll be using some shortcut keys that I like, some favorite. So I'll be telling them before I do them. All right, I hit F5 here to reset my view. So if F5 locks or looks at the pivot point on the screen. So there's a bunch of them if you want to study them and have a look at them. And then we've got our tools here. So the select tool, the display tool, all the menus that we went through at a high level are all listed here. So you guys can look at them. And system requirements, license activation. So this is the online help, really well built, and you can refer to it at any moment. Back to Cloud Engine now. So every time that you fire up Cloud Engine, you are going to land on this project window here. What do we have in this project window? Well, we have the name of the current project. So every time we start it up, it just starts as an untitled project. We can rename it in this box here. We've got our project coordinates that we can set. So it's either the Cloud Engine internal coordinate system, or if we're using a project coordinate system, we're coming from Revit with a base point or shared coordinates, we can set it to project coordinates, and then we will see real project coordinates and not internal Cloud Engine project coordinates. It's been improved in the last release. We can see the base point too. So if we're pulling in something from Revit with a shared coordinate and a base point, we can know where the base point is by clicking on this little icon here, and then our angle to north if we've got rotation to north when we're exporting. Under the desktop tab, we will have our recent projects that were open, so we can refresh our history. We can configure our root folder. I'll come back to this in a few seconds. We have a settings tab, which honestly, I've never changed anything under this tab, but if you guys want to check out the ambient light or diffuse or specular light, go ahead and look at it, but never played around with it. Under preferences, sometimes here I'll change a few things. So we can toggle the autosave project if we want. If you guys are used to having the panel on the left rather than the right, you can switch it from the right or the left. You can change your background colors. So if you want a solid color or a gradient or a vertical horizon, a virtual horizon, sorry, you can do so. You can change the colors. When we select objects in the object lister, or we can click on the point cloud or the object, the color will change. So we can change our selection color here. Cloud Engine allows us to program some scripts. So if you guys are good with Python programming and you're like, I'd like to have a little command or feature to do this or that, you can program that script, paste it in that folder, and it's going to be available inside Cloud Engine. The engineers at Cloud Engine are very proactive. So if there's things that you'd like us to see or do, let me know. I can reach out to Cloud Engine and they can tell me, yeah, it's already existing, or here you go, it's done. And share it. I had that in the past a couple of times. The filter radius here, by default, is set to 24 meters when you fire up Cloud Engine for the very first time. The X7 scanner that you guys purchased has a range of 80 meters. So let's import all of the data that we can, and then we can filter out and crop out the points that we want. So maybe you want to have a look at this and make sure it's set to 80 meters. If for some reason, oops, sorry about that, hit the escape key, you forget about it, you'll see it later in the import process. And if you're like, oops, I forgot to change it, you can either cancel your import, come back and change it, or you can complete your import and re-import the scans after changing your filter radius. Create spherical images captured by LiDAR scanner. We want to toggle this. So we want the 360 images that the scanner takes to be computed, and we can look at them. And don't check the last option here for intensity adjustment. It doesn't give a good rendering. I don't really like it. And the last tab, last but not least, this is your license. So you'll see how many days you've got left. And if you want to deactivate your computer to pass the key to someone else, you can click on deactivate this computer and it's going to release the key and someone else can use the key. If there are updates, you'll see them here. At some point, it's going to be listed important update or update is available, and then you can click on it, download it, and install it. And it shows you the latest version. So sometimes if you guys down the road reach out to me, JP, we're having issues, we've got a bug, I may ask you what version you're running. Just go to the license tab and give me the version that you guys are running. Back to the desktop tab here, I'm going to talk about the root folder. So every time that we create a project inside Cloud Engine, it will store it in a root folder. That root folder is by default on the C drive under documents. I'll go here, documents under the C drive, and it's called Bloom CE. This is where if I create a project and I don't change anything, the project goes under that Bloom CE folder. I like to be a little bit more structured on my data management or my project management for archiving and making sure that this Bloom CE folder doesn't come a mess. Now, on my laptop, my disk is split it in two. So my C drive is everything that's installing programs, blah, blah, blah. And my D drive is where I store my data and I work with cloud projects because I have quite a few. So I have moved my Bloom CE folder to my D drive. All right, but keep in mind that C drive, for you guys that don't have partition disks, documents, Bloom CE, this is where the root folder is. So my root folder is here, Bloom CE. You can see I got 210 gigabytes of point cloud data or projects. And those are all projects that I have created at some point inside Cloud Engine. So if I go here to root folder, it will point to D Bloom CE, and that's it. But I don't want all my projects to go in the Bloom CE folder. I want to drill it down once more. So before I do anything, what I'll do is I'll go under my File Explorer, under my root folder, Bloom CE, and I will create a folder of my own. So this will be PML training. So you have to create it in the File Explorer. You can't create it from Cloud Engine. So under my root folder, Bloom CE, I now have my PML training folder. In this folder, this is where I'm going to go and copy my TZF exported scans and my IFC model if I have a model, or my DWG, or whatever model file I want to be using. I'll put this up front. I know I've got TZF scans for sure. I know I have a model file. So what I'm going to do here, I went before while we were talking, I got some TZF scans and I've got a IFC model that I am going to copy. Let's pretend that this is coming from my external disk drive. My TZF scans, you see underscore TZF. So those are the scan files. And this IFC model I got from an export on a network drive or whatever. So I'm going to paste those in my root folder for the PML training project. And I'm going to paste them right here. Now I've got my scan files. If I open this, you see those TZF scans. Those are the points, the scans from the scanner. I got 19 in here, and I have an IFC model that I also want to be using. So I'll store them under my PML training project. I'll come back to Cloud Engine under my projects property window, and I'll make sure that this root folder, when I click on it, I can change it and make sure to drive it to my documents, Bloom CE, PML training. This is my root folder. This is where I want to create my Cloud Engine project. So once I've set this, I'll come here and I'll call this training day 1. And you have to hit the enter key on your keyboard for the project to be renamed and created. And it has to be the enter key on your alphabetic keyboard. If you try the numerical keyboard, I'm trying it at the moment, nothing happens. All right, numerical keyboard, a numerical enter on the keyboard doesn't work. So you have to hit the alphabetic enter, just like I did. And now you see it moved up. My project is now called Training Day 1. Training Day 1. And if I go back to my File Explorer, you see under my PML root folder, I had my model file, I have my TZF scans, and guess what? I now have my Cloud Engine project. If you don't drill it down by one, like I did, all of these folders are going to go under the Bloom CE folder. This is not the end of the world, but all of your model files and your TZF scans are going to be kicking around this folder. And then when it comes time to kill or to archive a dead project, well, you'll have to figure out which one was the TZF scan and the model files that I used for that PML training project. They're scattered across the board. But it's up to you guys, but I like to regroup everything under the same folder. So root folder, create a project of your own, paste your scan file, your model file, make sure that inside Cloud Engine, you click on the root folder, point to your PML training folder, and then name the project. And now you are all set. You're ready to import some scans in this project. Any questions? Make sense?
Yep.
All right.
Looks good.
Step number one, we're still at step number one. So we created a project. Now we want to import our scans. We're going to go to the import menu here. And because we've set our root folder in the PML training, because we've dropped our TZF scans in that folder, well, guess what? They're right there. I don't have to go and seek on my external disk drive or on the network drive or in another folder on my computer. It's already there. Nice, easy, direct access. Now I've got a bunch of files in here, like 1.tcf and tpf and tzf. Tzf contains the point cloud data. TPF, TCF are the image files. They're kind of linked and they ride along, they tag along with the TZF scans. So I am not going to be going and selecting these scans one by one. It's going to take me forever. What I'm going to do is go to my file types here and say, I want just the scan data to be visible. There you go. I just got TZF scans now that are available. I'm not going to import the 19 scans just for time efficiency here. Let me go with 1 to 9. Oops, sorry. 1 to 8, 9. And click on open. So this will launch the import. As easy as that. The import is sequential. It's going to import scan number 1. Once it's completed, it's going to do 2 and 3 and 4 and so on. So you can see that it's actually working on 1 and the other ones are queued for import. In a few minutes, when it's done importing the first scan, it's going to give me some additional information on the import status. You see this box just showed up here. So it's actually telling me that the software is processing 10 million points in 18 seconds. This is based on your computer hardware, RAM, and stuff like that. So you might do it on your end and say, hey, GP, my computer is way better than yours. That's good news. And it also gives us the approximate time to finish. This is not 12 minutes, 57 seconds. This is the time. So I'm out in Quebec City. It's currently 12:55. We're going to be done in 2 minutes importing. This is what it means. And it's not like Windows guesstimates. It's usually pretty good. If it tells me it's going to be done at 12:57 my time, it's going to be done in 2 minutes because it's 12:55. And we have our filter radius. So like I mentioned, as we were checking, if you forgot to change it and it's still set to 24, you can always say save and cancel the rest and restart your import, or go and adjust your import filter and your filter radius and then re-import. But once you've changed it, it's always going to stay to 80 meters, or if you're in millimeters, 80,000 millimeters. So it shouldn't be too long. As soon as the scans are going to be imported, the next step, a very, very, very important thing that I want you guys to do at all times is going to be to build your object transform hierarchy. You remember that tree branch leaf concept? Super, super important. Because if you don't build it right after the import, and by accident you move scan number 6 or one of the scans, well, guess what? You just broke registration. The registration, you just broke your puzzle. So you just took a part out. What do you have to do to fix it? Well, you have to put it back in place. You guys are like everybody or all of us, you got no time. You're under pressure, you're stressed, you need to produce. It's always fast track. We don't want to waste time with something that's already been taken care in the field. So it's going to be super important to lock the scans so they don't move. We don't want to break the registration. It's like applying the glue to our puzzle. We don't want the puzzle to be broken anymore, but we want to be able to move it around, right? We might not be able to move it around if it's locked. So what we're going to do is create that branch where we can move the branch around, but the leaves are not moving individually. So my 9 scans were imported, and we can see the result on the map in the map here. So I got those markers represent where the scan was located, and I just imported 9 scans. They got listed here in my object lister, and I have an object called imported data with scans from 1 to 9. This is where every time you guys import scan data, it has to be automatic that you come here, you select your 9 scans, and you lock them. So you click once to enable the lock, a second time to lock them. So my 9 scans are now locked. They will never move again. I will not break the registration. But I'd like to move this point cloud at some point elsewhere. Line it up over my model because my model is going to be elsewhere, right? Well, how do I do this? Because they're already selected, I can just right click and say group. Now I got the branch. Now I can move those guys around. So I'll rename this here. I'll call this, I always rename it raw scans. So you see now I've got leaves that are locked. Oops. And I have a branch that's not locked. So I can move the branch around, but the scans won't break. They're going to stay together. That's super important. And every time I get online with a customer to help them, that's the first thing I look at. I look at their object lister, and if I see that they're not locked in group, I say, hey, before we go any further down the road, would you mind locking your scans and creating a group? Super important. Oh yeah, sorry, JP, forgot about it. If you want to stay out of trouble with Cloud Engine, this is something you guys want to do. All right. So I got my raw scans in. So if we look at a few UI here, so zoom in, zoom out with the middle mouse button, rotate with the left mouse, or sorry, right mouse button down, hold the left, hold the right. Yes.
Yeah, sorry to interrupt. Sometimes it just happen, like they say we forgot the lock, okay, and then we move. If there's any way that we can bring back on the right position?
Yes, we can. There's different ways to go about. Sometimes Control Z, undo, will work.
Yeah.
Sometimes it won't. I don't know why. I haven't understood why, but sometimes it'll say Control Z and it doesn't do anything. And sometimes you'll do it and you're like, oh, phew, saved my rear end. So that's one thing. The other thing is you could bring it back to where it was and redo the registration with the transform tools here. We could go to registration and line it back up. Or we could say, all right, I moved 6, I broke it. You can come here, say delete, and just re-import 6. And it's going to fall into its place, its original place.
Okay, gotcha.
Awesome. So orbit was the right mouse button, hold it down, and you can rotate. Left mouse button will do a selection. So you see I clicked in the map and it selected scan number 1. If I click in this area, this is scan number 5. If I click over here, still number 1, still number 5. We got a few scans here, but This is the selection is the left mouse button, and if you hold it for a long press, you get a contextual menu with different options depending on which command you're in. You can reset the view to the pivot point with the F5 short key. So if you're down here and you're like, I'd like to bring this all the way or back to the center, if you hit F5, it's not working. F5, not working. All right, I know why. Sorry about that. Hit the little house, it will reset the view. So that's my bad. Sorry about that, guys. So that's going to reset the view. The F5 that I was trying to accomplish that didn't work for this, you need to set your pivot or your orbit point. So if, as at the moment, I'm orbiting from the center of the point cloud, you can see that the center is my orbit point. But I'd like to orbit from this corner around here. It's going to be a quick right mouse click. So if I click very quickly with the right mouse, you see it puts a sphere. And now you can see that I'm rotating around this pivot point. Now, if I hit F5, it's going to recenter the view on this pivot point. See how it got this right in the middle of my screen? So sometimes you'll see you're trying to move around and it's kind of lagging, or you want to go in this area and it's kind of a struggle. What I do is I set my pivot point, right click with my mouse very quickly, and I hit F5 and it just resets my view in the center. And now I know I can zoom in and look around. All right, so we can see the size of the points. They're set to 1 currently. Personally, this is personal preferences. I don't like working at 1. I find them too coarse or too big. So I'll bring it down to 0.5. You see how the point size got smaller? So the bigger, the coarser. I don't really like the rendering, so I usually try to work around 0.5. It makes it a little bit, but personal preferences again here. So you see I'm orbiting from the back over there. So if I want to reset my view here, click F5, it's in the center. Now I'm orbiting from this area. Home resets the view. Spacebar will toggle between the top, the left, and the right view, and the home view. So that was spacebar that I was hitting on my keyboard. All right. So step number 1 is completed. We created a project under our root folder. We made sure that we had a specific folder for this project that we're going to work in. So we went to the Bloomsea folder, created PML training, under which I stored my scan files, my IFC model, and then I created my Cloud Engine project. Once I have my Cloud Engine project, I imported my raw scans, I lock them, and I group them as soon as they're imported, so I won't break any registration, and I'll still be able to move them around. So that's what we've done up to now. So step 1, check, we're done. Step number 2, we are going to do today, because I was asked how we could line up a point cloud on a wall or stuff like that. And in our introduction, at the beginning of the training, some of you guys were talking about as-builts, floor flatness, maybe clash detection will be something you guys will want to be looking at for those as-built and clash detection analysis to happen. And sometimes for floor inspections, well, we need a model file, right? So I'll show you guys how we get model files inside Cloud Engine. So we're going to go back to our import menu, which will come up in a few seconds. And we will be able to import model files. What file types can we import inside Cloud Engine? We've got the DWG file. We got IFCs, DWF, DGNs, DAE, FBX, OBG, DXF, STL, PLI, SAT files that are also supported. If you want to be efficient and stay out of trouble, go with DWGs for 2D drawings and IFCs for 3D models. You won't have any issues or problems. When you're bringing in 3D models, I see this often on the steel side of things. I don't know about you guys, but I'll bring it up anyways. In the steel world, we can have bolts with washers and nuts, and we can have 20,000s of them in a model. So when you import an IFC that has 20,000 bolts, 20,000 washers, and 20,000 nuts, well, it's all objects that the software has to process. Makes it very long. So if you don't need those small parts and pieces, don't export them from Rivet. If you need the walls, the openings, and whatever, just keep it lean and clean. That's my point that I want to be making here, is when you're preparing a background file for Cloud Engine, stick with what you need. If I just need the walls, the pipes, and the grid lines, create your IFC with those elements. Don't say, I'm going to bring in everything with the light fixtures and the interrupters and everything. It's just objects that the software Cloud Engine has to import, manage, render. And if you're doing a deviation analysis and you got 20,000 bolts, 20,000 washers, and 20,000 nuts, well, guess what? It's going to have to go through each of these items to run the deviations. So it's going to make your processing time a whole lot longer than if you were just looking to check 25 columns, right? So be cautious.
Can I just
Yes.
ask a question?
Yes. So,
So do I understand it then? We're importing or exporting, I guess, from our Revit project to a .ifc,
yes, that's right.
and that's what's going to have to be
Imported in Cloud
links or
Engine.
imported to the cloud.
Yes. And with Revit, you'll export using the shared coordinates. We're going to set our project coordinates inside Cloud Engine to world coordinates or project coordinates, and then get the IFC in.
Okay, I have a little experience with .ifc, but I know that they're tricky to work with. So is there like a tutorial on how that part is done?
It's well,
because I know there's a lot of different settings and some
yeah,
of which you don't need and some of which I
I'm
know
not a
nothing
Revit
about.
expert. I know inside Tekla we can have like the IFC, the coordination view and the fabrication view, and we can select different objects that we want to export. It's usually pretty, maybe you'll have to do it once or twice, it's try and miss, and then you say, all right, this is the one and this is how we want to get it out. I don't have anything specific, but willing to help when you're at that stage and you say, JP, just get on a quick call and we can work it out together. But it's usually pretty straightforward. If you guys want to stay away from IFCs because you're like, we don't like IFCs for whatever reason, you can always export a 3D DWG. That's possible too from Revit, I guess, to save it as a 3D DWG. So those are the CAD formats we support. So if I go to IFC, I'll select my chiller replacement and I'll say open, and it's going to import that model file. So if I hide my scans because they're grouped, I can turn off the branch and you'll see that all the scans are going to get automatically hidden. I now have an IFC model available to work out of or work from. All right. So one thing I want to do to follow my logic, when you import data inside Cloud Engine, I just imported this model file, right? This is the center of the universe. I don't want this object to move at any moment. What am I going to do? Apply the lock on it. This time around, you can see it's already, because it's a model file and it's got layers, it's already structured in my tree branch leaf hierarchy. So I got, those are the leaves here. And this is a branch, and that might be the tree. I'm going to lock it at the highest level. So you can see if I lock the model, everything underneath gets locked. I can't unlock a leaf. It's not possible to unlock it because it's locked at a higher level. It's different than here. The way I did it, you remember, guys, I selected the scan files and I applied the locks, and then I created the branch. My branch is not locked, so I can unlock my scans. I can unlock my scans, or they're hidden, so they won't unlock because they're hidden. But if I make them visible, I can unlock them individually, right? And lock them. Because my branch is not locked, I'm just going to hide them again. But the way I did it here, rather than locking them individually, I lock them at the highest level. So this model here is never going to move, and that's what you want. This is the truth, the center of the universe, and I don't want this to move by accident. I had some customers call me up telling me, JP, I got this IFC inside Cloud Engine. I line up my point cloud over it, and when I export the point cloud, it doesn't land on my Tekla model. What the heck? Started looking at it with the customer and said, why don't you report your original info, re-import your original IFC? He re-imported the IFC and it landed elsewhere. I said, well, at some point you must have moved your model and you didn't notice it and you got caught. So it's super important to lock your things when you bring them in. And that was the end of the story. Customer said, oops, you realigned everything, send it back to Tekla, and it landed one on top of each other. All right, so we got our model file. We got our scans, but this is not where it should be, right? There's a little bit of an offset. Now I want to line up this point cloud over my model. How am I going to go about doing this? Here's how I will do this. If I'm right, this chiller here is in the back here. All right, so I know where I have to bring it. So what I'll do, I'll go in a top view. You guys remember one of the concepts in Cloud Engine, selection, action. What do I want to move? The point cloud, which is the branch. I want to move everything, not just one scan, because I'll break my registration. So selection, I come in here and I select the branch, and then I go and select my action, which is transform, transform. Because my object was selected, I now have the gizmo, and I can grab the gizmo, and you see I'm moving the entire branch around. So what I'm going to do is, I know I have to turn this guy 90 degrees because this here, this corner here is this wall here. I know it. Most of the time you guys will know your project. So I'm going to rotate it. So grab the blue circle. I'm going to turn it around like this. And then with the arrows, I'm going to grab it and come and sit it close to where it should be. So it should be somewhere around here. So I'm just going to eyeball it from a top view, and you'll see in a few seconds how we're going to drill this down. So from a top view, I did my rotation, did my translation, roughly eyeballed it. I can switch to a front view or a side view and see how am I doing elevation wise. So I can see the floor, I can see the floor. Well, let's try to nail this close to where it should be. All right. So rough positioning of my point cloud over my model. Now, my bad, I forgot to talk about the three methods we have to line up a point cloud over a model, and I jumped the gun and started with my favorite method. So I'll just do a short stop here to tell you the three methods we have to move the point cloud over the model. The first one I started showing you guys, it's moving the point cloud manually over the model. Millions of points don't lie, and when you land it at the right location, you can be pretty tight and pretty confident that your positioning is within a couple of millimeters of where it should be. I'm a big fan of that one because it's easy, it's quick, and I think it's as accurate as the two other ones. So method number one, manual lineup. Method number two would be a best fit. We then ask the software to best fit the point cloud over our model. This works well if we have a lot of overlap between our point cloud and our model. So if I'm working inside a building, I got 4 walls in my model, I've got 4 walls that were scanned, I can do a best fit, and it's going to fit it as best as it can. So if I have very little overlap, so if I have just the existing site conditions that were scanned, and my model doesn't have the walls, but just some hangers and some pipes, you won't have a whole lot of overlap between your model and your point cloud. So best fit probably won't work good for you. But you may say, well, I know the flange I need to connect to is right here. Well, then you're going to do a manual placement and bring your point cloud or over your model where the flanges are supposed to connect. So best fit of the point cloud over the model can be a good way to go about. What I dislike about this one is that it will distribute the error everywhere. sometimes in fabrication, especially in the steel industry, also probably in the MEP world, you have a baseline, you have a datum or a start point that you're starting from, and then you're going down, right? So if you do a best fit and it splits the error across the board, well, you may end up being off 2 inches, or sorry, half inch on your starting flange and half inch on your ending flange. Well, this is not what we really want. Let's set our starting flange to be dead on manually, and then we can cut the end flange by, by an inch, rather than have it 2 cuts to do. We only have 1 to do if we place it manually. You get it? Makes sense? So best fit could be used in certain scenarios, especially in fabrication. If you guys are checking a new tank that you're doing in the shop, best fit can be your ally. But sometimes it's going to be a manual placement because you want to check from the beginning, the starting flange to the end flange, and say, well, all right, we're long by an inch. Let's do 1 cut at the end and we're good, rather than having 2 cuts to do on each end.
GP,
Yes,
how do you do the best fit?
you go to the transform tool here to registration. It's going to come up in a few seconds. Come on, come on, come on. And then, sorry about that. I don't know why it does this on my computer when I'm streaming on Teams. So here you got those two options here that will allow you to do a best fit or align the point cloud over the model, and it's going to give you the residuals. So it's under the transform tool, registration, and you select this option here. That's method number 2. Method number 3 would be by doing a georeference. What the heck's a georeference, GP? This requires the use of a total station and setting up targets in your scans that you're going to survey in with the total station, export the coordinates of those checkerboards, and then inside Cloud Engine, you're going to import that CSV file, which is going to build a network of checkerboards in a world coordinate. And then from your point cloud, you're going to go and tag or mark those checkerboards in your scan, and you're going to tell the software, please fit my network of checkerboard over the geodetic network. So it's going to do the translation rotation over the real world project. But this requires you setting up checkerboards before you scan, requires a surveyor to come in and tie those in with the total station. And then you have to do the georeferencing, which is survey control here, to line them up. Requires a bit more work, but some scenarios will require georeferencing. In your world, I don't think this is required. You're going to ask me, well, when is this usable? It's when you want to check deformations over time. So let's say that GC is doing a renovation on a historical building, and he wants to monitor if the facade is moving as he's digging on the side of the building. Then he may scan at the beginning, then start excavating, scan after week 1, and then scan after week 2, and then scan after week 3. Well, if we do a manual placement of the point cloud, then there's a bit of play. We're doing it manually, and people will not like it. They'll take you have to be georeference. You have to be starting off the same datum every time to check if the building is going under some deformation. That's when people want to do georeferencing. All right. So again, sorry for jumping the gun and directly going to manual alignment, but I will say that probably 95, 98% of the placements that you're going to do are going to be manual placements. So what did I do? I started off by selecting the object that I want to move, which is my point cloud. I went to the transform menu, transform, selection action, select what I want to move, then select my action. I rotated my point cloud because I know the corner of the wall that I had in my model is this corner here, using this gizmo here, and then I used the arrows to line it up roughly. I went to a front view, line up the floor with the floor. So I'm close to where it should be, but this is not perfect. And you guys are gonna like, GP, you're okay, but you told us we could be a few mils drilled down. This is where I'm going to change how I'm going to fine tune, or I'm going to flip to fine tuning the positioning now. So fine tuning for this, what I'll do a clipping box because I don't see anything inside. I don't have anything to kind of guide me. So I'm just going to go with my display menu up here to the model view. So I got a clipping box now that I can adjust in size and focus on where I want to be working. So I'm going to put my pivot point right on top here, and I am going to lower my clipping box here. Like, JP, you're not clipping. That's how Cloud Engine works. It never clips up front. So what you have to do is go to your tool window or toolbox here. And this is where you manage your display here. So the first button here will toggle the clip. Now I'm clipping, and now I can say, all right, I can see this here, and what I want to line up, I know that those two front posts here, or do I see the wall? Yeah, we'll go with the wall. Let me lower this clipping box a little bit more. All right. So what I want to do is position this corner here right over the point cloud. So what I'm going to do, I'm going to go back to top view. We can see that I got my model and I got my point cloud. And I'm probably going to go with this corner here because it's this corner. Here we have something that's not giving me the corner. So I got my clipping box. I want to go back to my transform tool. You guys remember selection action. Select my raw scans. Select my action to be transform. So I still have the gizmo, but this is not very convenient for me at the moment because I want to fine tune this and I want my anchor point to be the corner, not this corner. Let's go here. I want this corner here. I'm going to decide myself at one point. I want this here. I want to land it close to where it should be around this area here. So what I'm going to do is I'm going to do a long left mouse press and set the transform pivot point right there. And I'm going to switch method. This is the 3D gizmo, gives me rough positioning. I can go up and down, rotate, but I'm going to change to something a little bit more fine here. And I'm going to use this second option in my transform tool, which will allow me to move the point cloud along the x-axis, y-axis, or z-axis. So you can see now that I can slide it with my mouse in a much smoother way than with the 3D gizmo. So I'm going to line up, the points here and move it up here. So you can see I'm running along the wall here and I'm running along the wall here. I'm starting to be pretty keen on where this point cloud should land. Millions of points don't lie. But I'm playing with my mouse here and it may be a little bit difficult to like land it directly on it. So what I'm going to do is I'm going to use my keyboard to fine tune this positioning. I'm going to strike or depress the Alt key. Sorry, not strike, but I'm going to depress the Alt key. And with my keyboard arrows, I am going to make this point cloud. You can see slowly how it moves to the left and to the right. And I had the same bug last week. I told the engineers, they said, no, we don't see this bug. And I gave it a try and it was working and now it's not working again. All right. In theory, I should be able to move the point cloud left and right, up and down. All right. So now it's only working left and right, but this is how you can fine tune and it moves by increments of 1 millimeter. So I can nail it down pretty tight. I can see the points are running along the wall, points are running along the wall. I'm pretty satisfied where this point cloud is actually sitting at. Millions of points don't lie. So I did the fine tuning in X and Y, sitting at the right location. Then what I'm going to do is I'm going to check at the rotation. I rotated manually at first with the 3D gizmo, but maybe I'm not running along the walls all the way through the other end of the project. So I'll zoom out a little bit. And yeah, guess what? You can see that the point cloud is kind of like moving away from my model. You guys see this? So I do have a rotation problem. Same thing when I look at it on this side, I can see the wall. This is the wall here, not being on the wall. So what I'm going to do, because I've set my pivot point, I decided that this was my anchor point right there. I'm going to leave it there, and I'm going to go to the rotation menu. Now I can rotate around the z-axis, the x, and the y. I really want to rotate around the z-axis with a very little increment. So I could grab this circle here and rotate it, but you see, the further I move my mouse away, holding the left mouse button down, the smoother the rotation is. But it's not going to be easy for me to land it right on where it should be. You can see that went, oops, too far, too close, whatever. So what I'm going to do is I'm going to make sure I set my rotation transformation around the z-axis, and I'm going to enter a very little angle. And when I hit the enter key on the alphabetic keyboard again, you'll see that it's going to rotate by this very little amount. You probably didn't see it that much. So what I can do now is depress the Alt key, and with my keyboard arrows, you can see how it's now slightly turning or going very slow. So I can then come and line up the point cloud. So usually what I do, I go as far out as I can, leaving my rotation pivot point way out there. And then you see I can fine tune it. You want to try to be as further out away as you can, so you have a longer baseline, a better adjustment. So now those points are running along the walls, pretty good, pretty solid. If I come over here, you can see that, yeah, the points are running along the wall, pretty good. You can see that the model here, no, it's a little bit, either the model is too long here, or we could decide if we want to move this down a little bit, because here I'm on the walls, but you can see that here, I don't know if you guys see this very well, but we've got a gap. Could be the model, could be the design, who knows? So we can look at the columns. We can see that the columns from the model are a bit off. So it all depends on what we're doing. So you see, guys, I decided to make this my pivot point and my anchor point. But if I look at the columns, you can see that they're all decaled, right? This is the model, and this is the as-built.
There you go.
Maybe the
JP,
columns are what I should be using to do this alignment, and maybe the wall, I know what I'm doing. This is the inside of the wall, it's not the outside.
there you go. That's what I'm thinking.
Thanks, Melcher. I'm being a bit stupid here. Sorry about that, guys. So what I'll do, I'll go back to this menu here, and I'll say, all right, let's move this in, and let's move this like this, and now this should be, makes more sense. So you see, the teacher can be stupid sometimes. So now it makes more sense. Now
Actually,
I'm
it's
one.
been scan inside, so I was thinking it should be showing
Yeah.
inside.
Yeah. Sorry about that, guys. So I got it landed where I want it now. X and Y and rotation is good. There's one last thing I want to do now, and it's the elevation that I want to check. So for elevation, I'm going to change the way I do this. So what I'll do, I'll go back to my scope box, and depending on where my benchmark is or the place I want to set the elevation to, I'll scope a thin slice in that area. So I can see the model. So I don't really see the model very good here. So let's pretend that we want to go from the corner of this wall right here where I put my dot. So this is where we want to decide to start off from. So you can see that the point cloud is just a little bit higher than the bottom of my model. So I want to move this guy down. I'll go back to my transform tool. So I'm going to select my object, selection, action, transform. And now my pivot point is elsewhere. So I'm going to bring it back to here. So I'm going to hold my left mouse button down and set my transform pivot point. And now I can grab my blue arrow and move it up or down. But again, I'm using my mouse, and it'd be hard to land it dead on because of my mouse pad or my mouse, whatever. Maybe a little bit lower or maybe a little bit higher. I want to fine tune it. Depressing the Alt key and the arrows only works from a top view. It doesn't work from a side view. So I can't use my Alt key here and my arrows to move it up or move it down. But I got my elevations here. That point cloud is sitting at 6.4 mils. What am I going to do? I'm just going to put in 8 millimeters. See how it rose by a few mils? I'll bring it back to 5. It's going down. So this is how you fine tune it. I mean, I can put 4. Yeah, maybe 4 is good. Maybe 5 is a little bit better. I like 5. So you can fine tune it and drill it down and be like dead on. All right. So if I let go of the clipping box, my point cloud is now positioned over my model, and I'm satisfied with the results. I did X and Y, rotation, and then elevation, and it's right where I want it. What will I do at this stage? Super, super important. I'm going to lock the branch. I don't want this point cloud to move again. The leaves can't move. They have to move as a group, but now I don't want the group to move anymore. So I'm going to turn the lock and I'm going to lock this object. Now, even if I'm selected and I go to transform, it tells me here the raw scan group is locked against transformation. You can try to do whatever you want, JP. The gizmo's not showing. I got nothing. Even if I try to move it, it tells me you're locked against transformation. So you're never going to break it. It's always going to be laying or sitting exactly like you positioned it. Any questions?
Sorry, JP. So what's gonna happen here is like, let's say in my case, we're gonna scan the site. After that, we model the piping and everything, and then we're gonna lay out everything inside. And then in that case, on us built, we have to rescan again, and then we going to import again and Trimble Cloud engine. So we have to realign and everything process again, right?
Yes, so if I understand correctly, you guys are going to go scan the existing conditions,
Yeah.
get it in Cloud Engine, clean it up, and then
Yeah.
either you'll get your grid system or grid lines from Revit just to position your point cloud, and then you're going to go in Revit and start detailing.
Gotcha. Yeah.
And then you're
And-
going to say, all right, we're going to take that new detailing, we're going to go and install, and we're
Yes.
going to rescan again.
Gotcha. Yeah, that's it.
Yeah. All right. Well, yeah, you'll have to bring it back and realign it. But you know that geo referencing that I was talking about,
Yes, the third option.
I don't want to get you guys confused at this time because you guys are still learning Cloud Engine, but we could take advantage of this workflow if you want to avoid repositioning, because if you're like, I'm going to reposition it, I may have a little bit of error. You're right, you may have a little bit of error, but you saw how accurate I could drill it down and rotate it and place it. I mean, all right, if we're 2-3 mils out, not the end of the world.
Yeah.
But if the project manager or the people you're working for say we're not into manual positioning, we don't trust you, we want something geo-referenced, then you say, all right, we'll geo-reference. Let me call JP and I'll tell you what to do to realign it at the right location.
Thank you.
Thank you very
I'm
much.
sorry, just to add to that a question. Do we need additional equipment or anything for that third option for geo referencing? Or
I
is it
have a
all
very
there?
short memory. I'm really bad at it. I don't know if PML, you guys purchased a robotic total station. Do you guys have a robotic?
We have a total station, yeah.
You have a
for
total
Trimble Field
station
points.
with Trimble Field Link and Trimble Field Points. Yeah, so then you guys would be good to do a geo-referencing. You have all the tools and the knowledge or the skills to do it since you own a total station.
Great, thank you.
Welcome. I've been talking about for an hour and a half. Does someone need a break? Do you guys want to take a 10-minute break, or we can keep on going? Your call. I'm good. I can do this all afternoon. I love it. But if you guys want a bio break, coffee, smoke, we can take a short break, 10 minutes if you guys want.
Sure. Let's take a break.
Sure. So
Yeah, we
let's
could probably reconvene in time.
yeah, break it. Let's break it for 10 minutes. So come back at 1:45 my time, which is probably 10:45 your time, if I'm right.
That's good.
Good stuff. So I'll stop the recording and we can reconvey in 10 minutes.